Okay, so another presentation from LINX staff now. So I'd like to welcome Mike Hellers to the stage, our product manager, to walk you through some updates to our product set.
Hello. I'm going to talk about a product, a service. I think it's unlikely that you're ever going to use it, but hey. That's setting the tone, isn't it? So this is, I mentioned this a couple of times. This is probably a service which many exchanges introduced 10 years ago, 15 years ago. We've finally done it as well. I still think there is a use case for it, and weirdly enough, it still comes up. We still get the question from members on a fairly regular basis why we don't offer it. So we decided to go ahead and actually implement it. I said, I think it's unlikely that you're going to use it. We're going to come to that. So I don't know, do I have to explain what remote triggered black hole is to anybody in the room? Let me explain it. It is really a very rough method that can help you protecting your infrastructure, your network, in case of a large, especially large volumetric denial of service attacks. It basically allows you, I don't know, you have one IP address in your network which is being attacked. It allows you to announce that very specific IP address, that prefix, /32 or /64 if it's v6, to your upstreams, or in this case, to your IXP, to the root servers, and basically tell your upstream, drop the traffic that goes to this IP address. And I come back to it a little bit, but obviously, while you kind of do the job of the person who is attacking it, since you complete the attack, since you basically take that IP address off the network, but it allows you to protect the rest of your network. Since if you are under a very large attack, even though if that traffic is only to one specific IP address, the volume of traffic might mean that actually your whole network is not reachable since your ports are congested. So there is a use case for it. And if it's implemented at internet exchanges, normally the way it is implemented is very simple. You announce the IP prefix that you want to be black-holed to the root servers with a well-defined BGP community. The root server changed the next hop of that prefix to kind of a black hole server, black hole destination, specific destination on the peering LAN, and basically we will drop every traffic that goes to that next hop. It's a fairly simple implementation, but there are a number of limitations, and we'll talk through some of these. As I already mentioned it. So remote triggered black hole, you always complete the attack, but it allows you under some conditions to protect the rest of your infrastructure. But in the end, you do what the attacker wants. You take that IP address down, even if he hasn't managed to, you take it down. But it also requires your peers or upstream to accept, in most cases, more specific, since normally you obviously only want to announce a /32. So if you send it to your upstream, they need to accept it. If you send it to a root server, the root server needs to accept it. We're going to come back to that in a little bit. There is, again, it's probably 10, 12 years old. There is an RFC, I think it's 7999, which defines some guidelines that really says, as an operator, you really should accept prefixes that are tagged with the black hole community, even if otherwise you might reject them. When RTBH was designed the way it is, really prefix validation, and especially RPKI, wasn't really as big of a thing as it is these days. And we definitely don't want people to stop validating prefixes or implementing RPKI. But fortunately, the two don't really fit very well together. But as I mentioned a couple of times, there might be still some use cases where it is useful to have, and in the end, as I said, it's the reason why we have, in the end, implemented it. It is actually implemented, and Mo, correct me if I'm wrong, it's live on LAN 1 and LAN 2, and the work is currently being done on all of the other exchanges to bring it there, and I assume it's going to happen over the next 2-3 months, probably on the remainder of the exchanges. And the idea was always, well, if we offer it, we want to make sure that it's available on all of the exchanges that we operate. And again, the implementation is very much standard. We're using the well-known, well-defined BGP community, 655.35.666. There are the next top IP addresses, MAC addresses that are there. It means in theory you can also use it without root servers. You could obviously set the next top to these ones. It still means that the peer that you're peering with isn't going to enforce strict next top validation, since he might not like that if you do it. But again, there might be use cases where this works. Once it's live on the other LANs, we'll publish these as well. The documentation is gonna be available probably as soon as we're done here. So it's very standard implementation, very similar to all of the others. Yes, I think I talked a little bit about some of these already. Do I really need to use the roots? Not really, but the restrictions still apply. Can I still limit, can I still use the other communities on the root servers? Can I only announce it to some of the root server peers? Yes, all of that still works. You can combine communities. There's no issue there. Do I need to add no export? Please don't add no export to it. The root server will add no export to the prefix when it announces it to the other neighbors, to the other root server peers. So you please don't. If you do, the root server is going to respect the no export and by default not export it to anybody. So what did I not mention? I mentioned that you're probably not going to hear it. So the way it is currently implemented, I actually think it's not very likely that it's going to be of use. So at this, and which is really what I'm trying to say on this slide, we're still looking into this and trying to improve it. So currently, it is probably the strictest possible implementation, maybe the most secure implementation. It means if you're using RPKI, if you want the root server to actually accept your /32, it's only gonna accept it if it passes RPKI validation, which means it either has a rower for that /32, or you have defined the max lengths up to /32, which is really not recommended. You shouldn't really do that. So it's probably unlikely that the root server actually gonna accept your /32. You would have to jump through quite a lot of hoops to do it. Even if you would add a rower for the /32, updating RPKI rowers isn't the fastest thing either. So I think there are a couple of corner cases where this might be useful. But really, we're looking for feedback. I think that there's a couple of other implementations that we could have chosen and that we might be looking at to make it a little bit more flexible. It always comes a little bit at a price, since you kind of cheat with the prefix validation, any kind of workarounds that you implement. So we do certainly welcome any comments, any feedback on this. I think there's also ways to make RTBH bring it a little bit into this century rather than last century. I do think we probably want to look at, well, do we actually want to filter the traffic on our edge without relying on announcing it to the peers? I think there's lots of things that can be done. In the end, it exists now, pretty much standard. You can use it if you think you can use it. I had a look at the Looking Glass, and there always seemed to be, even before we introduced it, there always seems to be quite a large number of prefixes out there being announced that have the black hole community. I'm not sure what the point is, but I looked on RS1 or on one. I think I saw around 900 prefixes currently being announced with the community. They're all being rejected by the root server, but they're there. Anyway, remote triggered black hole at LINX. It's there. Talk to us. What do you want to do with us? Question.
Hiya, 2 questions.
Sure.
Will there be an update to the technical MOU 4.5 about next tops being advertised over the peering LAN?
I was kind of expecting it. So yes, you're correct. Currently, the MOU wouldn't allow you to change the next top.
Okay.
Yes. Even though I mentioned that in theory you could, and we probably wouldn't enforce it. But yes.
Okay.
If we would want to cause trouble, it would be a breach of the MOU. But I do think, I really do think that actually if you as a member change the next top, even though we kind of allow you, even though the MOU doesn't, I do think a lot of the other members, a lot of peers will actually reject it, since they will probably fail the strict next top validation at their end.
Yeah, I suspect anyone who's peering with the root servers, unless they have a different peer group for the root servers and their bilateral peers, will probably accept it anyway.
Yeah.
And the MOU does allow us to do this if there's agreement in writing from LINX. So even without changing the MOU, you could probably put an agreement on the website saying you may use these next tops if you want to black hole traffic there. The second question, you're saying about it being the most strict implementation possible. Does it actually check, do the root servers actually check that the black hole route is coming from the current favored source of the covering prefix?
Okay.
So for instance, if I had AS-, let's pick on Amazon, in my route set,
Yeah.
would you then go and accept a black hole route from me for Amazon's IP address space, even if I'm not currently the favorite for Amazon's IP address space itself?
Well, there's two things. So what you're talking about is would the root server, which one would the root server choose? Since if the root server would accept it from you, obviously it will, and Mo is going to correct me if I'm wrong, it will have to pass the prefix validation that we do, meaning we check. So if there is an API carry, so we'll check if there is one. If it's valid, it's gonna pass.
Yep.
If it's not, it's gonna get rejected. If it's unknown, we're gonna do the IRDB-based validation. So that's gonna, you need to pass that before the root server will accept it, independent if it has a the black hole community or not.
So some transit providers, what they do before accepting a black hole community is not just check that the host route will pass validation, they also check that that customer is the customer that is currently the preferred destination for the covering route.
Okay, we don't.
You don't, okay.
Yeah,
Is
currently
that
we don't.
something you would investigate?
I'm certainly more than happy to. Which is, in the end, one of the main reasons of talking about it. Get feedback,
Okay.
and more than happy.
Great, thank you.
Okay, thank you. Any other questions about this before we continue? No? Good. So what else? There must be more about DDoS. I can't stop talking about DDoS. So we also, and some of you know already this, we are also currently working with one of our partners, in this case Nokia, to actually investigate, well, is there anything else that we can offer? Again, this is probably also a little bit of a niche use case, but we do know that we have a number of members, probably mainly members with let's call it smaller members, which doesn't really mean anything. I'm not, but members which probably were connected at lower bandwidth, especially if you're connected at large peering LANs like LAN1, and you're connected with a gig or 2 gig or 3 gig. It's actually quite easy to have your port congested. Your port is kind of exposed to the big bad world of the internet out there. So it is a question that comes up quite often, and we fairly regularly have discussions with people, with networks who would want to use an internet exchange, but simply see it as too high risk to expose the edge of their network to that. So this is one potential solution that we have been looking into. As I said, we're currently doing a proof of concept with Nokia. Some might know it. Nokia have a scrubbing-based DDoS mitigation platform called Deepfield. So the idea is that we would host that platform. It's connected, be owned by LINX, connected directly to the peering LAN, but running Nokia's Deepfield platform and allowing you to basically redirect the traffic that would end up on your port, redirected through the Deepfield platform, do proper scrubbing-based DDoS mitigation and only let clean traffic end up coming through you. It obviously removes a lot of the limitation of the remote triggered black hole. It is proper full DDoS mitigation, of course, still only for your peering traffic. So this doesn't replace any other solutions. This we won't be able, so the RTBH, it's just a service that's there. You don't have to charge to use remote triggered black hole. This obviously we can't really offer for free. So this will be a paid service. The timeline for this is really, as mentioned, proof of concept is currently being done. Hopefully a rollout to LON 1, hopefully early second half of this year. Potentially also LON 2. In the end, we can probably use the same physical platform for both LANs. And then really it depends on demand and feedback that we get if we're going to look into rolling it out to other peering LANs as well. Again, come talk to us, ask us questions. If you're interested, we're more than happy to talk to you. Last one, just a couple very quick updates, and I'm sure there's more presentations about LINX Nairobi. So it went live not too long ago. We had a lot of questions, a lot of requests really from the networks down in Nairobi about private VLAN closed user group, mainly private VLAN. So that's pretty much live now. So private VLAN and closed user group are available on the Nairobi exchange pretty much now as well. The same for the Microsoft Azure peering service. A lot of you might remember it. In the end, it's peering with Microsoft AS8075 without some of the restrictions that normal peering has. You don't have to fight with the Azure portal. We can do that for you. There is really no peering policy, no minimum or maximum requirements, and even in some special use cases, if you don't even have a /24, if you only have a /29, you can still peer with AS8075 by using maps. We started with having that on LON 1 a couple of years back. We introduced it in Nova and Manchester last year. And we now also bring it to Nairobi. We obviously only offer it there where we have Microsoft, where we can have that local interconnect directly with Microsoft, since otherwise kind of defeats the purpose. So that's also going to go live probably a little bit after private VLAN and closed user groups, since there's obviously cross connects to bring into service. Actually, I think at the moment we're waiting on IP addresses first, but that's going to come soon. And I think that's all I have to talk about. Any more questions from anybody?
Hi, sorry, this is back on the DDoS theme again. It's something that I've mentioned to you before, and there was like some vague enthusiasm or interest, at least, both from yourself and Curtis. And I was just looking back through my email history, and it's actually over 5 years since I first mentioned this. It's the suggestion that LINX could deprioritize common DDoS traffic on egress. And I know that some of the largest tier 1 transit providers already do rate limiting on this. I know of some of the other transit providers also do a similar thing with deprioritizing this for their customers, but sadly not for their peers. And it was basically a case of like things like NTP replies, charging replies, memcached replies, SSDP replies, that kind of thing, just shoving into a low priority queue. Not limiting them, but just shoving it into low priority queue, which would give a better user experience for all of our customers at practically zero risk and at zero cost, because it's always on. It's just there when you need it. There's no reaction required. The equipment that we're using already has this. Is it something that LINX would maybe give a little bit more priority to, or at least say we're not interested in doing this?
It's a tricky one, since I do think there is, you can probably split the membership into multiple groups, and there are probably some members who would probably say, well, we really don't want you to touch the traffic at all, so everything would need to be kind of opt out, which is a little bit trickier for something like this.
It's just two different QoS profiles. You can either opt in or opt out to the.
Yeah, you can't really opt out of it though.
If it's egress to their port. Then...
If it's egress to their port, yes. So you would have to do the egress to their port.
Yeah. Yes. That's the only place it would be applied is on egress.
Yeah. I think it's an interesting approach, and certainly I wouldn't completely ignore it. I think it's certainly worth looking at it again.
Yeah, I've had it deployed on my network for probably 8 years now, and it really does just make most volumetric DDoS is a non-event. I think Neil's got something he wants to say.
Yeah, if you can do it on your own network, why don't you? I personally wouldn't want LINX switches wasting CPU dealing with bad traffic. I'd like to make sure that they route my traffic to me, and if I need to deal with it, I can. CPU. If it's not going to, if it's in the switching path, it's not going to use any CPU. Yeah. So you've got a much more complex config. You've got to then deal with that config. I may know something a little bit about router configs now, James. And you know, it's not as easy just to deprioritize something, and then you start to use buffers. And then if you're using certain chipsets, you're going to run out of buffers potentially, depending on how big the attack is. If there's a way you could build this so that you could not have to deal with it at the LINX, I would be all for it. But it's just genuinely, from what I know, and before I was never a fan of this, I'm even less of a fan of it now. So good luck to those who want to do that, and especially with certain types of chipsets. And what's your biggest flow, James?
Can you wait for microphone?
In terms of what's the biggest flow you've ever seen on a network? The point is depending on the biggest flow and the number of flows that you get will have a different impact.
Okay. Do you have any specifics in terms of what is the next?
Off the top of my head, no, but let me. Perhaps it would be a useful presentation to give.
I will look forward to yours.
Okay, I will dig one out.
Thank you both. See, when I said there might be different groups in the membership. Thank you. Any other question?
Nope. Okay.
Thank you.
Thanks, Mike.